In the last episode, we introduced the effective flow of water that's running up the wave face. And in this episode, we're going to talk about how the surfboard interacts with that flow of water. A surfboard can grip the wave because some of the water moving up the wave face hits the bottom of the surfboard and flows around the soft inside rail of the board. In the vast majority of cases, this is what holds your board into the wave, not your fins as most people think. As far as physics is concerned, water is actually very sticky. So when it flows along a surface, it will follow the curves, and this attraction is what gives the board grip. A great example of this is to hold a spoon under a running faucet. If you hold it upside down, the water flows along the curved surface and actually sucks the spoon into the water flow. This holding power and the point at which water releases from a curved surface rather than gripping can be predicted by a calculation called the Reynolds number, a dimensionless quantity that is used to predict flow patterns in fluid mechanics. In the case of a rounded object in water, i.e. the rail of a surfboard, the speed of the water and the radius of the curve can be used to calculate the point at which the flow of water will release from the curve, with faster flow and tighter radius causing earlier release. This means that thicker, softer rails riding on smaller, slower waves will have much more hold in the wave face than a thin rail at high speeds. So how does your surfboard generate speed? While some of the water that flows up the wave wraps around the inside rail and holds the board in the wave face, the rest, the majority in fact, hits the bottom of your surfboard and is directed along the length of your board to exit out through the tail. Newton's third law of motion dictates, more or less, that every action has an equal and opposite reaction. So when we redirect that effective flow, your surfboard is acting as a hydrodynamic foil to create lift and forwards thrust. For every litre of water we can redirect, we'll get around 2 pounds of lift and thrust, causing you to travel faster across the face of the wave. Concave or channeled bottom contours are designed to redirect as much water as possible along the board and out past the fins, whilst convex bottoms shed water out towards the rails, so are slower down the line but facilitate easier turning as they transition from rail to rail more readily. The importance of generating speed, of redirecting as much flow as possible along the length of your surfboard, rather than shedding it off your rails, is why locking in your inside rail and taking a high line is such an important habit to form. This illustration shows 3 waves and 3 surfers in 3 different positions. The first surfboard is in trim on a high line across the wave and is creating as much lift and thrust as possible because the bottom of the board is perpendicular to the flow of water running up the face of the wave. Most of the water making contact with the underside of the board is being redirected out through the tail. The second surfboard, trimming along the bottom of the wave, where many beginner and intermediate surfers find themselves, is actually in the worst place for generating speed, because it puts the rail of the board at a shallow angle relative to the flow of water, so much of that flow will run across the bottom of the board and spill off the inside rail. The third surfboard is also at the bottom of the wave, but by banking over into a big bottom turn, the flow of water is hitting the bottom of the board at 90 degrees. This surfboard will actually be going the fastest, as it was able to generate speed using gravity when it dropped down the face of the wave and is now continuing to generate speed and not lose it as it turns. That means that it's possible to come out of the bottom turn with more speed than you took into it, and actually go back up the wave face faster than you went down it. For this reason, the most efficient way to surf a wave is with a gentle roller coaster ride up and down the face. However, in order to make this work, you must master the timing and technique of the bottom turn. The next best route is to angle your takeoff and take a high line along the wave. This is easier to learn and will give an intermediate surfer more time on the open face of the wave to practice their turns. In the next episode of Surfing Explained, we're going to continue to explore the areas of surfing to help you improve. But for now, thanks for watching.